Hey folks, today's topic is the unit circle. So this is kind of the cornerstone, the foundation of all trigonometry. So it starts with thinking about how could we measure, what are some ways that we could measure a circle? What does that mean to measure a circle? So there's two different ways that we could measure all the way around the unit circle. We could talk about these things called degrees, and that's where we break up this distance into a certain amount of a rotation around the circle. So degrees are rotations. So if I were to rotate 30 degrees, it would take me about to here. If I was to rotate 90 degrees, it would take me up to here. So I'm taking the radius and I'm rotating it some angle around the origin. So that's pretty standard. That's what we are used to looking at. There's another way to measure around the unit circle, and that's these things called radians. Radians are a measure of length. Oops, let's try to spell length. Wait, was that right? Yeah, that was right. No, that's not right. How about that? Is that how you spell length? All of a sudden my brain is freezing on how to spell length. Length. Geez, I keep spelling it the same. I keep spelling it the same way on my. All right. Sorry. Let me get back on track here. Let's try it like that. Look at I keep putting the H on all these. I just kept spelling it the same way. Length. How about that? There we go. Radians are a measure of length around the unit circle. So if I rotate all the way around the unit circle, I would rotate how many degrees? It's a measure of rotation. This would go 360 degrees. Well, if we set up our circumference formula, if you remember circumference equals 2 pi r, we're going to assume this is called the unit circle, and unit just means 1. So that the unit circle means that the radius is 1. That's all the unit, that's what I mean when I say the unit circle. So if the radius is 1 and I do 2 pi r, circumference is equal to 2 pi, but our radius is 1, we would get that the circumference is 2 pi. So the first thing you want to understand when it comes to the unit circle is this connection between degrees and radians. 360 degrees is equivalent to 2 pi radians. So in other words, rotating 360 degrees takes me all the way around the unit circle, or going a distance of 2 pi along the circle would also take me all the way around the unit circle. So radians are a measure of length. Degrees are a measure of rotation. And depending on what perspective you're going to use, you could look at the unit circle from either perspective. So let's, you guys have probably thought of this before, but here is a picture of the unit circle broken into with a compass placed on top of it. So we have 360 degrees, we got 90, 180. Most of these you'll feel pretty good about. The important ones, the angles that we really care about is the 30 degree, the 45 degree, and the 60 degree. Now the 90 is going to play a role in there anyway also, but all these other degrees, all these other rotations, all these other lengths are always going to be multiples of those values, those 30, 45, and 60. So let's take a look at where those things would live. So if I took, let's start off, let's think of it this way. Let's go back to our unit circle. Okay, so where is the unit circle? Is a very logical thing. When I started teaching trigonometry, I actually used to just hand out a picture of the unit circle and said, here you go. It's much better to think about why the angles, the rotation angles of degrees are same as the radian measures of length and how they interact with each other. So let's start off. Where do you begin when you're thinking of the unit circle? We always begin here. We consider this to be 0 degrees. We consider this to be 0 radians. Now, radians you don't usually put units with. If you're talking about degrees, you must write the degree symbol. When you're writing radians, if you don't want to write anything, that's fine. Or you can write, like I wrote up here, RAD is the unit for radians. Okay, so that's where we begin. This is the quote-unquote origin if you're thinking of the unit circle. This is still the XY axis, but we're moving around the unit circle. So this is still 0, 0, I agree, but we have to be on the circle when we're thinking about the unit circle. So this is where we consider 0. Now we could pick anywhere to be 0. It would just rotate everything a little bit. So mathematicians chose this spot to be 0. Then, what we just talked about, a full rotation around the unit circle would take us to 360 degrees, or how many radians? 2 pi radians. Now, everything follows logically from this relationship, that 360 degrees and 2 pi is one full rotation, one full lap around the unit circle. So let's say we go halfway around the unit circle. Halfway around the unit circle would take us to right there. Well, what's halfway of 360 degrees? Would be 180 degrees. What is halfway to 2 pi? That would be 1 pi. All right, so I think we had talked a little bit. We talked about rotating. All right, so just to reiterate, sorry, I had to take a phone call, so if I'm repeating myself, sorry about that. So one full rotation around the unit circle is 360 degrees. That can be measured as a rotation of 360 degrees. These things called degree, 1 degree, 2 degree, 3 degree. Then we also have this radian measure, which is a measure of length. So how far you go, this actual circumference around the unit circle is 2 pi. So full rotation is 360, full rotation is 2 pi. If you remember that, everything else just follows logically from there. So halfway around, half of 360 is 180, half of 2 pi is 1 pi. And then let's do that again. Let's go half again. So what's half of 180? Would be 90. What's half of pi? Well, pi over 2. 1/2 pi is pi cut in half. Okay, so this is going to be the first time we're going to start to count around by a radian measure. Well, let's do it by 90s first. So this is 90 degrees. Where's my next 90 degrees? Is 180. What's another 90 degrees? That's a new point, so I'm going to identify that. 90 plus 180 is 270. What's another 90 degrees is 360. Okay, now let's do that same thing, but let's do it in terms of radians. So this is 1 pi over 2. So this is 1. What's in front of that pi is 1 pi over 2. What's another pi over 2? So this would be a distance. This length is what we call pi over 2. If you could measure that, that would be a distance of pi over 2. Pi over 2 plus pi over 2 would take me to here. That would be 2 pi over 2. The 2 over 2 reduces, so we don't have to write it because this would be 1 pi over 2, 2 pi over 2, 2 over 2 reduces, and we just get pi. Then we would go another pi over 2. So this is 1 pi over 2, 2 pi over 2. This would be 3 pi over 2. Then I would go another pi over 2, and that would be 4 pi over 2. 4 pi over 2 reduces to be 2 pi. So if things reduce, I'm not going to write a new point. I'm going to always reduce them and clean them up. So these are what I call the corner points. I know it doesn't make any sense to call them corner points, because this is a circle and a circle doesn't have any corners, but that's the terminology that I use. So let's practice counting around a certain number of radians. Let's go with 11 pi over 2. All right, so this is 0. I always start at 0 radians, 0 degrees. Now I'm counting 11 pi over 2s. That means I'm counting 11 gaps of pi over 2, or you can think of that as 11 gaps of 90. So 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, and then we would just keep going another gap of 90. 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, 9 pi over 2, 10 pi over 2. This is the location of 11 pi over 2. So that's what I mean by counting around by a certain unit. We could also go backwards. Now, when I count, I go counterclockwise, but that's because all the rotations I've done so far have been positive rotations. I could also go negative. Let's go to negative 5 pi over 2. So negative 5 pi over 2 means that I'm going to go a distance of 5 pi over 2, but in the negative direction. So negative 5 pi over 2, that would be 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2s. So this is the same as negative 5 pi over 2. So we went all the way around the unit circle, then we cut that distance in half, then we cut that distance in half, and now we're going to cut this distance in half again, and we get, usually it's easier to do degrees first. So what's halfway to 90? That would be 45 degrees. Now, if I go 45 degrees and another 45 degrees, that would be 90 degrees. Then if I go another 45 degrees, that's going to leave me right here, exactly in the middle. Okay, so that's 45 and 45 is 90. 90 and 45 is 135 degrees. Another 45 is 180. Another 45, okay, that's new. Try to mark it exactly halfway. So 180 plus 45 is 225 degrees. Then we would go another 45 is 270 degrees. Another 45, 270 plus 45 would be 315 degrees. 315 degrees plus 45 gets me back to 360. Okay, now let's do that same thing, but do it in radian world. So how do you figure out what this measure is? Well, I always think about it in terms of how many of these, how many lengths of 45 degrees would I need to get to, how many gaps of 45 degrees would I need to get to 180? So I would go 1, 2, 3, 4. So this degree is the same as pi cut into 4 pieces. So halfway around is pi. If I start to make tick marks based on 45s, I would get 4 different sections. Another way to think about it is pi and 180 are the same thing. So if I do pi in my head, I'm saying 180. 180 divided by 4 is 45. I mean, the same thing works with 90 too, right? Think about pi. When you see pi, I know we usually think of 3.14, but when it comes to trig, we usually want to think of pi as being 180. So what's 180 degrees divided by 2? 90. Also, how many 90s do I need to get to 180? I need 2 of them. That's why it's called pi cut over 2. So this is pi cut into 4 pieces. Now that we've got this identified as 1 pi over 4, each one of these gaps is a pi over 4, but we want to count around by pi over 4s. So this would be 1 pi over 4. This would be 2 pi over 4. Why don't we write it? 2 pi over 4, it reduces to be pi over 2. Then I go to 3 pi over 4. That does not reduce. 3 pi over 4, another one would be 4 pi over 4. 4 over 4 reduces. Then we get to 5 pi over 4. 6 pi over 4. 6 and 4 are both divisible by 2, so I can clean that up. 6 pi over 4 becomes 3 pi over 2. That's not new. 7 pi over 4. And then 8 pi over 4. 8 over 4 reduces to be 2. All right, so let's practice counting around again. Let's count around to, I think I like 11. I always use 11 usually. 11 pi over 4. So that's 1 pi over 4. That's 2 pi over 4. 3, 4, 5, 6, 7, 8, 9, 10. That's 11 pi over 4. 11 pi over 4 and 3 pi over 4 are the same thing. Let's have you count around to negative 9 pi over 4. All right, negative 9 pi over 4. Pause it, count around on your unit circle, and then unpause it and see if you got to the right spot. All right, negative means I start here and I go this direction. I'm going gaps of pi over 4, so that's 1 pi over 4, 2, 3, 4, 5, 6, 7, 8, negative 9 pi over 4. You should have stopped here. So the other two angles that we care about, the other two measurements, I should say, that we care about are the 30 degrees and the 60 degrees. Let's do the 60 degree next. Now, 60 degrees. 60 degrees is 2/3 of the way towards the 90. 60 degrees is past the 45, but think about it this way. Is 60 closer to 45 or is 60 closer to 30? 60 is much closer to 45. It's actually 2/3 of the way closer to the 45. So I'm going to make my tick mark the best I can. I'm not going to put it in the middle because it's not halfway. But that would be, it's not great, but it's pretty good. 2/3 of the way. So this is 60 degrees. Now let's count around by 60. And this is the first time that you're going to skip over a previous measurement. So 60 degrees takes me here. 60 degrees, well, this is 30 degrees. I would go another 30 degrees. So yet again, I'm 2/3 of the way closer to the 45, and this would be 120 degrees. So I talk about 90s as being hidden 45s. So if you go 45 and 45, you'd hit 90. 60 is not the same case. 60 jumps right past 90 into a new thing called 120. Now, if I go 60 again from 120, I'm at 180. So 180 degrees is a hidden 60 degrees. Now from the 180, I want to go 60. So this is 45. I want to be 2/3 of the way closer. 180 plus 60 is 240. 240 degrees plus 60, 30 degrees takes me here. 30 degrees would take me here. So that would be 300 degrees. And then 300 degrees plus 60 would take me back to 360. Let's see if you can figure out. You don't have to write it down. Just think, what do you think this would be in radians? Remember, pi over 4 was because pi and 180 are the same thing. And 180 divided by 4 makes 45. 90 is the same as pi over 2 because 180, pi is 180, divided by 2 is 90. So what do you think this would be in radians? Let's see what you did. So if I took 180 and I divided it by 60, I would get 3. So this is the same as pi over 3. I would need 160, 2 60s, and 3 60s to get to 180. So now let's count around by pi over 3s. This is 1 pi over 3. I would skip the 90. This would leave me with 2 pi over 3s. Skip the 45. This would be 3 pi over 3s, but the 3 and the 3 reduce and just leaves me with pi. Then I would go another 60. That would take me to, so that was 2, this was 3, this would be 4 pi over 3. 60 jumps past the 90, would take me to 5 pi over 3. And then 6 pi over 3, 6 over 3 reduces to be 2 pi. And then the last one that we look at is 30 degrees. So 30 degrees is 2/3 of the way closer to the 45. Okay, where's my next 30? 30 and 30 is 60. That's old news. I'm not going to mark it again. So 60 is a hidden 30. 30 and 30 make 60. 60 and 30 make 90. That's a hidden 30. 120 is a hidden 30. Then I finally get to a new spot, 2/3 of the way closer to the 45. So 120 plus 30, this is 150 degrees. 150 plus 30 is 180. 150 plus 30, okay, that's new. That's 210 degrees. 210 plus 30 is 240, plus 30 is 270, plus 30 is 300, plus 30 is 330 degrees. And then another 30 would take me back to 360. Let's see if you can now figure out the measurement in the world of radians. What's the length from from 0 radians to 30 degrees rotation? Here's how I remember it. I just remember it's always going to be 180 divided by this number. So 180 divided by 30 is pi over 6. 180 divided by 30 is 6. Or I can think of how many gaps of 30 it would take to get to 180. 1 gap, 2 gaps, 3 gaps, 4 gaps, 5 gaps, 6 gaps of 30. It would take 6 30s to get to 180. Now let's count around by pi over 6s. 1 pi over 6. Skip the 45. This is 2 pi over 6. Why don't I have to write it? 2 and 6 reduce. This is 3 pi over 6. 3 and 6 reduce. 4 pi over 6. 4 and 6 reduce. 5 pi over 6. That's new. Also, 5 and 6 don't reduce. 6 pi over 6 becomes 1. 7 pi over 6. 7 and 6 don't reduce. 8 pi over 6 reduces. 9 pi over 6 reduces. 10 pi over 6 reduces. And then we get to 11 pi over 6. And then 12 pi over 6 takes us back to 2 pi. Okay, so there's all of our rotations. Let's practice counting around now by a couple different things. Now, I'm just going to say it because I don't want you to write it on here. You can't add things. If you need to get out a separate sheet of paper to write it, that's fine. Let's have you count around to 11 pi over 3. 11 pi over 3s. Okay, so hopefully you paused it. If you haven't paused it yet, pause it real quick. So 11 pi over 3. So first of all, you got to think of pi over 3 and what that is in degrees. So that's 60 degrees. So I want to count 11 gaps of 60. So here's one gap of 60. Then my second gap of 60, I'm going to jump past the 90. That's 2 pi over 3s. I'm going to jump past all these. These are 3 pi over 3s. Jump past all these. These are 4 pi over 3. 5 pi over 3. 6 pi over 3. 7 pi over 3, 8 pi over 3, 9 pi over 3, 10 pi over 3, 11 pi over 3. So this is the same as 11 pi over 3. Let's try another one. Let's try negative 7 pi over 6. Pause it if you haven't yet. Okay, negative 7 pi over 6. So how far is a pi over 6? That's 30 degrees, but we're going in the negative direction. So I'm going gaps of negative 30. So there's negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. This should be negative 7 pi over 6. And there is a trick that your negatives will always be a reflection over the x-axis of the angle. Like negative 7 pi over 6 is a reflection across from the x-axis from regular 7 pi over 6. Let's do one more. Let's do negative 8 pi over, well, that one's too easy because it'll come out. How about negative 9 pi over 4? Okay, negative 9 pi over 4. That would take me negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9 pi over 4. Now there's these corner points. I should have probably done this earlier. The corner points are actual points. Remember, this is the x-axis and this is the y-axis. So if this is 0, 0, and I went directly over 1, my radius is 1 because we're talking about the unit circle. If I go directly over 1, this is a distance of 1 in the x and 0 on the y. If I go to this location, that's 0 on the x and 1 on the y. So this is the point 0, 1. This would be negative 1, 0. And then down here, this is 0, negative 1. Now this unit circle, we're going to add lots and lots and lots of stuff to this. So keep this thing nice and neat and handy in your backpack or folder, wherever you put it. but you may not add anything without permission. So make sure that you ask me before you add anything to it. What I want to do now is I want to look at the homework set and do a couple of these together so that I can show you what I'm looking for. So in the homework, I want you to count off the radian or degree measure. Try to do this without looking at your unit circle, especially for my AP kids. You do not get to use the unit circle after pre-calc. You have to know how the unit circle is built and how it works from there. So anybody who thinks they're going to take calc at some point in their life, you don't have to memorize this. You just need to understand this section basically. If you understand unit 1 and then how the rest of it just follows from there, you don't have to memorize anything. You've actually learned it and you understand it. Those who are only taking pre-calc, and that's probably going to be their last math class, you can use the unit circle to double check your work if you need to. So I want you to count off the radian or degree measure. Try to do this without looking at the unit circle. Draw the triangle and label the reference angle. And I'm going to talk about what that reference angle is. So let's do one of these together. So 405 degrees. Where would 405 degrees? Well, first of all, 405 degrees is bigger than 360 degrees. So I want to figure out how far. So 405, take away 360. So that's going to be a full rotation plus another 45 degrees. So 405 degrees would take me all the way around, and then I'd go another 45 degrees. We make a tick mark there. Then when you draw a triangle, you always draw the triangle the same way. You draw two lines, one to the origin, one to the x-axis. Now look, this is your 90-degree angle. This is what we call the reference angle. So that would be the angle. See how you don't have to draw this for the x-axis, but I like to draw it at least once so you see that that's where the right triangle is. The reference angle is the angle emanating, we call it emanating from the origin, the one that comes out of the origin. So how many degrees was this? This was 45 degrees. Let's try another one. Negative 135. Well, that's another 45. I'm going to skip that one. Let's go over here to the negative 120. So negative 120 degrees. So I always think about it in terms of what are the nice, is this a 30, a 45, or a 60? Now you could use 30, but you'd have to count more of them. I'm going to count the 6 by 60s. I always pick the biggest one I can. So that's going to be negative 60, then a negative another 60. That's negative 120 altogether. You always draw the triangle the same way. From your tick mark, you draw one to the origin, one to the x-axis. Then using the x-axis, that makes the 90-degree angle. Now we identify the reference angle. Maybe I should go back here and draw an arrow. When I say reference angle, the reference angle is the angle of reference. It's the angle that's still inside. Now, inside the triangle. 405 is the actual angle, but the angle that you would use for reference in the triangle would only be 45 degrees. We're also going to use that angle as reference when we fill in the sides and start to label the side lengths of this triangle. So negative 120 degrees, what did we count by? Counted by 60s. So how far is it from 120 to 180? That's a gap of 60 degrees. So sometimes you have to do a little figuring, especially when it comes to degrees. You have to do a little bit of figuring of how big that reference angle is going to be. We always refer to the reference angle as the one from the origin, not this one on the edge. We never actually care about this one. We use it to look at once in a while, but mostly we only care about the one from the origin. Okay, let's jump down and try to do one with degrees, with radians. Now what's nice about radians, I can already tell you what the reference angle is going to be. Because if I cover up the 13, it says pi over 4. Pi is the same as 180. 180 divided by 4 is 45. So this means I'm going to be counting by 45s. So I'm going to count off 13 45s. 1, 2, positively. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, this is the one that I want. Back to the origin, back to the x-axis. There's my triangle. Now the reference angle is this angle here, but we counted all these gaps by 45, so I know that this angle has to be 45 degrees. Let's have you try to pause it and try to do part B. All right, let's see how you did. So this is a dead giveaway, folks. That's why we like radians so much. I already know what I'm counting by. Counting by 30 degrees. Counting by 30 degrees in the negative direction. So 30 degrees negatively would be 1, 2, 3, 4, 5, 6, 7. From there, I would draw 1 to the origin. Always, always, always to the x-axis. Never to the y-axis. And then my radian measure, my reference angle, would be 30 degrees. What do you think? So let's jump back up. Well, let's jump back up to part D. 900 degrees. Because I didn't show you what happens when we get to a corner point. So I'm going to take 900 degrees. I know that's more than 360, so I'm going to subtract 360. I'm at 540. I'm going to subtract another 360, and I get 180. So when I rotate 900 degrees, I would really rotate once, twice, and then another 180 degrees. Well, now we have a problem because I'm supposed to draw one line to the origin and one line to the x-axis, but this is already on the x-axis. When you hit any of these corner points, we don't label them as a triangle. We just label where it is on the unit circle. Like this corner point is the point -1, 0. So anytime you hit a corner point, just go back and label it -1, 0. So if you hit, let's say you hit down here, this would be 0, -1. This would be 1, 0. This would be 0, 1. All right, so I've got the answer key to this posted. I didn't have room to put it at the bottom, so you have to get on Classroom to check out the answer key. Good luck.